Chapter 3, Lesson 2 of Geometry, we're going to prove that lines are parallel. And we're going to look at the converses of these four theorems and the postulate that we looked at in Lesson 3.1. And again, if you remember from Lesson 3.1, we looked at these postulates and theorems, and all of them had the exact same conditional, if the lines were parallel. And if those lines were parallel, then the corresponding angles would be congruent, the alternate interiors would be congruent, the alternate exteriors were congruent, the same side interiors were supplementary, and the same side exteriors were supplementary. And again, we talked about these being conditional statements. If the lines are parallel, then the correspondings are congruent. Well, remember when we did conditional statements, if we took the converse, we switch the hypothesis and conclusion, and because these are good definitions, all of these are reversible, meaning that if we use the converse, those are going to be true as well. And if we use the converse, then the hypothesis becomes the corresponding angles are congruent, or the alternate interior angles are congruent, or the alternate exterior angles are congruent, or the same side interiors are supplementary, or the same side exteriors are supplementary. Any one of those 5 different conditions all produce the same conclusion. The lines are parallel, 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 because the condition to begin with on all 5 was the true. So if it was up to you, and it was your task to show that 2 lines are parallel, all you would have to do would be to meet one of those 5 conditions. So when you're looking at these diagrams now, what you want to try to identify or show is that 2 angles, if they're corresponding, are congruent, because if the 2 angles are congruent, then the 2 lines would have to be parallel. Okay? Or if the alternate interior angles were congruent, then the lines would be parallel. Or if the same side interiors were supplementary, then the lines would be parallel. Or if the alternate exteriors were congruent, then the lines would be parallel. Or if the same side exterior angles added up to 180, then the lines would be parallel. So if it's ever your task to prove that lines are parallel, then all you have to do is try to fulfill one of those 5 conditions, and if any one of those 5s are met, then you have parallel lines. So this entire lesson's all about doing that. So a quick example, here's a diagram, and we're given that the measure of angle J and the measure of angle L is equal to 180. So which lines would be parallel, and then how or why could you state that on one of these theorems? So let me turn on my little device here. So what they're saying here is that if I took the measure of angle J, which would be this angle right here, and I took the measure of angle L, which is this angle right here, they would add up to 180. Well, if I connect the sides of the angle, so angle J is this side along with this side. Sorry for my squiggly line there. Let me go back here. So if J, angle J, and here's L, well, you notice if I just extend angle L out and these sides, you'll notice that I have 2 lines, and then this line becomes the transversal. And so what kind of angles are J and L? Well, they're same side interior, and they add up to 180. So that means which lines would be parallel? Well, this line here, line LM, would be parallel then to line JO, because of the converse of the same side interior angle theorem. The converse providing that those angles are supplementary, then the lines that make those would have to be parallel. So that's how you would do that, using the converse of these theorems. So that's all you're going to need to do on each of these diagrams. I guess the one main point I want to make here is that whenever you're proving lines parallel, it's always going to be the converse of one of those theorems that you learned in the previous lessons. So make sure you use the word converse in front of the angle theorem if you're proving that the lines are parallel. Okay, meaning you didn't know they were parallel, but because they are, the lines are parallel, you're using the converse of each one of those four theorems or the corresponding angle postulate that you learned in the previous lesson.